Find the location of the local minimum and local maximum of the function f of x equals negative 2x cubed plus 30x squared minus 96x plus 8. Okay, so local minimums and local maximums occur whenever we have critical numbers, or I should say they can occur at these points. So critical numbers or critical values, these are values where the first derivative is equal to 0 or the first derivative is undefined. Now this is a smooth continuous curve. So there's no sharp corners in it, and there's no breaks or asymptotes or anything. So we don't have to worry about where the first derivative is undefined. But we do need to worry about where the first derivative is 0. So let's work on that. To do that, we need to get the first derivative to begin with. So that will be negative 6x squared plus 60x minus 96. And I'm going to set this equal to 0 and factor. And it might make things a little bit easier. There's a common factor of negative 6, it looks like. So that would be negative 10x, and what would 96 be? 16. Great. All right, so then plus 16. Notice I changed the signs on everything because I factored out the negative 6. All right, so that will factor. And if I change this into, let's see, 4 and 4 would be an 8 there. That's no good. How about 8 and 2? So if those are both negative, they would multiply to negative 16 and then add to negative 10. So that's great. So when I set this equal to 0 in order to get the critical numbers, it's pretty straightforward now. Just each factor would give me a critical number. So x equals 8 and x equals 2. Now, what I need is what's happening around these critical numbers. So I know that at these critical numbers, 2 and 8, I have potential places for minimums and maximums, but I don't know which one's which or if either of them actually are. I can't figure that out unless I know what's happening around those critical numbers. So for instance, if I go from an increasing interval to a decreasing interval, then that shows this critical number is a maximum. That's the thinking I need to go through. To find that out, what I'm going to do is do some test values into the first derivative. So anything on this interval is okay. So 0 is on the interval from negative infinity to 2. And how about 3 here and possibly 9? That seems like the smallest ones that would work. What I'm going to do is evaluate the first derivative at each of these points. And when I do that, let's see what I get. I just want to know if it's positive or negative. So this would be negative 6, because there's the negative 6 here. If I put in 0, 0 minus 8 is negative 8. 0 minus 2 is negative 2. I don't much care what the actual value is. I just really want to know if it's positive or negative. So 3 negatives make a negative. So that tells me my function is decreasing on this interval. Now at 3, I have negative 6 times 3 minus 8, which is negative 5, times 3 minus 2, which is 1. Negative times negative is a positive. So it's positive on this interval, which means I am increasing. 9, it would be a negative 6 times 1 times 7. So 1 negative, the result would be negative, which tells me I am decreasing on this interval. So what that tells me, I can interpret this as I'm going from decreasing to increasing, so this is a minimum value. I change from increasing to decreasing, so at 8 I have a maximum value. Now I don't know what those minimums and maximums actually are. Those are the y values associated with these. But I can say that I have a relative minimum of something at x equals 2 and a relative maximum of something at x equals 8. To figure out what those values are, I'll just use the calculator. So let's plug in the polynomial here. And this is the original polynomial, not its derivative, because I just want the y values. So negative 2x cubed plus 30x squared minus 96x plus 8. Okay, go into the table and plug in 2 and 8. So negative 80 and 136. So I have a relative minimum of negative 80 at x equals 2 and a relative maximum of 136 at x equals 8.